Hello, this is Jim Sevier with Convergence Readiness, and in this session of Shortest Path Bridging, I'm actually going to go through and talk about the resilience opportunities associated with Shortest Path Bridging and utilizing resilience as that door opener to gain access into the decision makers inside of pretty much any markets and most verticals within the IT departments of most markets and most verticals. So let's go through resilience. Remember, resilience we were talking about, look, we're talking about something that's standards-based. So resilience, yes, I know that has the connotation of making sure that it always stays up and running, but I think one of the significant elements of resilience is making sure that you've got a standards-based protocol to deal with. It's not proprietary. You're not relying on the manufacturer to pull this thing off. It's actually a standards bodies, and it works with pretty much everybody else's. Right? Could you imagine if Ethernet was a proprietary technology and you try to make everybody's Ethernet work together? So that's, to me, one of the significant elements of resilience that we're going to address today. As well, the ability to be autonomic. And I'll talk about autonomics a little bit further in, but if you're not familiar with what autonomics is all about, think of your own body and think of your nervous system. It's actually referred to, you have a nervous system which is autonomic in nature, which means you don't have to think about it to breathe, right? You can go to sleep at night and you're still breathing. But it's not just that simple. It actually responds to changes in your environment. The hotter it gets, the more your body perspires so that you can cool your body off so that it doesn't overheat. When you run, your lungs expand and your heart beats faster and your blood moves faster through your body to feed the necessary oxygen to all of those extremities that you've got running around. So the key here is understanding that really the next generation of traditional networking, legacy routing protocols, the next generation is a network that understands what's going on around it and isn't a statically designed and maintained element that is only good at that point in time that it's designed. Right? You're looking for an environment, a networking environment that could actually respond to external stimulus, like an application being added that takes more bandwidth and being able to automatically load balance that without having a human involved with making sure that that happens correctly. So load balancing is a big key element to this thing. And what we're really looking about as far as resilience is, we understand that networks do fail, that components do break down, and it happens. So one of the things about resilience is that it has sub-second recovery. That's the key to resilience. Yes, it needs to be resilient. Most networks in the traditional legacy routing world are resilient. But it's just the amount of time it takes all those bloated traditional legacy routing protocols to come back up because they're all dependent on each other. You can't build one till you build the other. Until you get all those protocols built back up, the network isn't fully functional. And by that time, you're into 2, 3, 4 seconds. It could be even longer than that. It could be up to 2 minutes before the network comes up, again, in very complex environments. So resilience is really a discussion of sub-second recovery. So we're going to talk about that. So let's go into a little bit more detail about the types of opportunities that you can use as door openers when it comes to resilience. So the very first one is what's referred to as an all-active infrastructure. And I mentioned it in the simplification video. I mentioned the ability for when you remove spanning tree from the equation, you basically get back all these ports because spanning tree shuts down ports in order to keep the network flat. Well, in the shortest path bridging architecture, since all ports know about all other ports, one port could be open when another port is millisecondly closed. So you can actually have information running around this network without actually physically creating a loop. So what you've got is the ability to have an all-active network or all-active infrastructure. And that means you're going to remove spanning tree and you're going to get a significant amount more throughput. You've now basically doubled your bandwidth without doing anything but just getting rid of that traditional routing legacy protocols that are managing the networks like spanning tree. And you're replacing that with shortest path bridging. And that is a significant enhancement to an operation. Again, you're basically getting twice the speed for just putting in shortest path bridging into the core of the network. And that's pretty significant. Now, a second opportunity for you is what is called an active-active carrier link. So you've got active-active carrier, and in this scenario, this is where you have duplicated data centers. So you've got duplicated data centers, and you've got site number 1 and you've got site number 2. In a duplicated scenario of data centers, and again, in traditional routing protocols, it's not easy to put together the traditional routing protocols to make both sites truly active-active. Usually one site is active and the other site is a backup, or it's not running live and is maybe only brought online to do backups and stuff late at night, right? So you're basically taking half of your connection to the outside world, half of that bandwidth is not being used, 70, 80, 90% of the time. So in a situation where you're trying to get resilience, duplicated data centers, but you also want performance and more throughput, the way to go is with an active-active carrier configuration. And the only way that you can really do that simply and cost-effectively is through shortest path bridging. Again, shortest path bridging is an anti-looping technology, so there really isn't going to be a way for these two carriers or these two sites to create a loop, even if they're both active, even if they're both running from two separate carrier service providers, even if they're running traditional routing protocols, IGP and BGP and all the rest of them that are out there that manage these connections. Simply putting a shortest path bridge in front of both locations, one at the primary, one at the secondary data center, and you will get an active-active configuration, and you will have an instantaneous and immediate results. And the customers will begin to see the value associated with shortest path bridging. This is really a key Trojan horse when you're really going after those opportunities, and you don't want to touch the data center, and you're introducing a relatively new protocol to the customer. So you don't want it to be something that is going to cause them to want to rip everything out overnight. But one of the things you can do is just add shortest path bridging to this configuration without removing any of the existing traditional legacy routers. Just add shortest path bridging on top and go into an active-active state for your duplicate data center, and thereby doubling the amount of bandwidth and throughput that you can get to and from the internet. So it's a pretty interesting design that you can deploy within shortest path bridging under the resilience category. Now the last piece to this, which is interesting, is load balancing. And auto load balancing, again, is a key attribute or key feature of shortest path bridging that you normally have to handle with traditional routing protocols in order to make it work. Load balancing is a significant enhancement to data networks because now it takes into account, it's not just, hey, I'm going to take half my traffic and put it on carrier 1 and half my traffic on carrier 2. It allows you to make the decisions as to when that traffic runs and how much of it runs, and by application what runs. So you've got really now more design elements that you can put into your architecture, your network architecture, based not only just on the bandwidth of the connection, but the applications that are running through those connections as well. So you get, from a resilience perspective, you get a significant amount of opportunities, either with creating an all-active infrastructure and getting more value from the products that you've got installed, or moving from an active standby to an active-active carrier duplicated data center configuration. That is a pretty significant play in pretty much every industry that's out there. And then the load balancing capability, where you get that automatic load balancing. So if you've got two sites and you want to get them load balanced between two locations, having a via Fabric Connect VSP4000, one at each location, you'll have immediate load balancing through the network on those two devices, just simply out of the box. It's just that simple. So let's go move on to the next video. But this is shortest path bridging. This is the resilience elements that you can bring to customers. And I'll look forward to seeing you on the next video regarding security and shortest path bridging.